Okay, so this is in your packet of notes. It's finding the inverse function. Okay, so when they're saying a function, oftentimes they're going to use this notation as f of x equals. One of the things that I like to do with these problems before I even begin them, because of, if you read the first step, you can see it says something about switching x and y. The first thing that I like to do is I like to rewrite my function with a y instead of f of x. It does, I think, make things less complicated for you. One of the things that we talked about in our discovery lesson here last time was the fact that from an exponential function to its inverse log function, the x and y's switch places. That also goes the other way around. If you start with a log function and you go to its inverse exponential function, the x and y values literally switch places from one function's graph to another function's graph. So if we are given a function like this one here in this first example as a logarithm, and they ask you to find the inverse, what they are asking you to find is the exponential function. So on these problems, what we are trying to do is trying to find the inverse exponential function equation. I'm going to say function equation because that's what it's going to be at the end. And you can write that on your paper here. So these are the steps that you take to do the problem, okay? You're going to switch x and y, you're going to isolate the function, and you're going to solve for y. And we will use a special notation called inverse notation to designate our final answer. I'll get to that when we get there. Okay, so I'm going to do the first one with you here, and then you'll have some example problems to do on your own or with the teacher. And just a heads up, I'm going to change one of these problems, so if you choose to not watch this full video, then you're going to do the wrong problem and you're not going to have all the examples. So on number 3 in the box below, if you could go ahead before we begin the lesson, change that problem to y equals log base 5 of x minus 4. You might think that's the same thing, but it's not. This minus 4 is not attached to the log, whereas before down here it was attached to the log because of that parentheses. So I wanted to do a different example there so you got like a variety up here. So please make sure to change that before we begin. Okay, so back up to this problem here. What you're going to do, step 1, you're going to go ahead and you're going to literally take this starting equation that you rewrote with a y and you're going to switch x and y. They're going to switch places. Like imagine that you and the person next to you switch seats. It's the same thing. So nothing changes except x and y switch places. So instead of y, it says x. There's still an equal sign. It's still log base 4. Okay, and instead of an x, remember they switched places, this is going to say y, and then you still have the plus 3. The plus 3 is not attached to the log because it doesn't have a parenthesis. This is log base 4 of y, and then they are adding 3. That would be different than if it was log base 4 of y plus 3, where this is all now one big thing. So pay attention to that. Okay, that's important to know because in the next step it says isolate the function. So basically what that means, it means I want to get this function, this log part, I want to get this alone. I want to get this part all by itself. So that means that this 3 needs to move on over to the other side. So to move a plus 3, we should know that we minus 3 to move it to the other side. So this will read as x minus 3 equals log base 4 of y. Okay? Now, I had mentioned this before that if you don't like the log being on the right-hand side, you can flip this whole equation around. We should understand that if we have log of the base of a number equals the power, that's the same as if I wrote this. Those are the same thing. But if you like the log to be on the right because that's what we're more familiar reading, please go ahead and rewrite this. But it's actually not really necessary, but you can do that if you want to. The next thing is we're going to solve for y. Now, you can't get y by itself by dividing by log base 4. That is not log base 4 times y. Log base 4 of y represents one whole function. So you can't separate those things. So remember, if you can't solve it in log form, if you can't solve in log form, what should you do? Well, what you should do is you should change to exponent form. And we've talked about what this change is a bunch of times. That is, if you can't change it in this form, change it to base to a power equals a number. That's what we mean by if you can't solve it in log form, switch it to its inverse. Remember, the way we solve equations is we use inverses. You couldn't do anything with this plus 3, so you used its inverse of minus. I can't do anything with this log, so I'm going to change it to its inverse, which is exponential form. So let's write the exponent form. What's the base? Well, the base is 4. What's the power? Well, logs equal powers. The power is this whole entire thing, x minus 3. You can put that in a parenthesis if you want. And then we have equals the number, and that would be y. And if you look, y is now by itself. Again, if you don't like that y on that side, switch this whole thing around. You can write it as, you can write it as y equals 4 to the x minus 3 if you like that better. Again, you can put a parenthesis around that if that helps. I like to do that because it kind of solidifies that it's in the exponent. The last thing we need to do is we need to write this in inverse notation. Inverse notation is actually really simple. They use what looks like an exponent of -1 to indicate that it's an inverse. And that just tells me that we're not dealing with the original function. So I wrote it up here already. F of x is your original function. Call it the OG, okay? And the inverse function is going to be f of, and it looks like there's an f of -1 of x. This is the inverse function, okay? So down here, instead of having a y, I want to write it in my inverse notation by using f of -1 of x. I'm just reading it. That's not really how you read it. It's an inverse function of x, but that's how you write it. F to the -1 of x. That's how it's like. That's what it looks like when you write it. And this should be in place of y. Okay, now the reason we want to write it with f of x is because this is written as f of x. So I'm going to write this as f of x with my little inverse notation there equals 4 to the x minus 3. And that is your final answer with inverse notation. You can see here that they have it written as y equals already. So the inverse notation, you can still use this. I always allow you to change it to f of x if you want to. But another way that you can write inverse notation is you can do y to the -1. So when you get to the answer of number 2, you can write your final answer when you do inverse notation as y to the -1 equals. And it's like blah, 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 right? Whatever you get on that. Okay. Now this one's a little bit different because on this one, it's exponential, right? So for this problem here, you're still going to follow these same steps though. You're going to switch x and y, isolate the function if you have to, and then you're going to solve for y. So on number 2, what you're going to do, first switch x and y. So go ahead. It'll be x equals 6 to the y plus 2. Now, the next step says isolate the function. Well, on this one here, there's nothing really to isolate because it is base to a power, where y plus 2, that whole entire thing, y plus 2, is in the power. And again, you can put the parentheses, or you can see how they wrote it there. They did not, and that's totally fine. But we need to solve for y, and y is in the exponent. So I talked about how if you can't solve in log form, change to exponential form. Well, you know what, guys? It goes the other way. If you can't solve it in exponent form, you need to change it to log form. So I can't solve for this y without getting it out of the exponent. The only way to get it out of the exponent is to put it into log form. So we're going to go back to this concept, except now we're going exponent form to log form. Okay, so when we change it to log form, first thing we do is we write the log. What's my base? It is 6. That's written little. Okay, and it's log base 6 of the number, so there's x equals, what do logs equal? They equal powers. My power is this whole binomial y plus 2. Okay, now remember, this step is solving for y. We have not yet solved for y. I'm past this. I'm at solving for y now. And I don't have y by itself. I need to move this plus 2 to the other side. So I'm going to go ahead and I'm going to subtract 2 on both sides. Okay, and I'm going to do minus 2, minus 2. So when you write this side, it's going to be log base 6 of x. Minusing 2 on both sides is going to be minus 2 equals y. Remember that this x is solo. This x minus 2 is not together. It's log base 6 of x, that whole thing, minus the 2 equals y. And again, if you like your y on the left-hand side, you can go ahead and write it on the left-hand side. Now, I had mentioned before that you need to put it in inverse notation. You can put f -1 of x, or, inverse function of x, but this whole system up here. But because they started it as y, you can end with y, but you still need to do inverse notation. So if you have y and you want to do inverse notation, keeping it as y and not changing it to this f of x notation, you can write this as y to the -1. That is your inverse notation. Again, that is not an exponent of -1. That is an indication that it is inverse. And the reason we know that it's an inverse is because that's what we're doing in these problems, is changing it to an inverse notation. So you can write it like that. If you wrote your answer on this one as if you wrote your answer on this one like this, right, I would absolutely accept that. You can go ahead and use that notation if you would like. Okay, but I usually kind of stick with, if they start with f of x, I end with that notation. If they start with y, I end with that notation. That's pretty common practice. Okay, so you can see there's another example. Number 4 is a lot like number 2. And then this example 3 is a lot like the one that we did together. So it's going to be really important that you try number 1 and you try number 4. I would say that number 3 is sort of like a bonus practice, but definitely try number 1 and number 4 to make sure you understand those, because those are different than the 2 that I've already done.